Hey, Carl here to say that Music to Code By is now an app called Music to Flow By. Now you can listen to the tracks on your phone with offline capability. The first 3 tracks are free, and the entire catalog is available by subscription with a new track arriving every month. Just go to musictoflowby.com for all the links. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
Actually home from Build while we're recording this.
But this is all out of order, isn't it? So,
it is.
Yeah. You're going to hear the Build shows later. This is earlier.
Right. But we wanted to do the show after Build just because of the content.
Yes, and the announcements. But of course, you've already heard the announcement show by now because the whole .NET Core 3 thing's out. Interesting problems. But good to be home. You red-eyed at home, my friend.
I did. I got like 4 hours of sleep, man. Wow. I slept with 100 people at the same time last night.
All your closest friends.
On the red eye.
Yeah.
Yeah.
You know, that whole we're all breathing the same air thing in the airplane, it's really not true. The air turnover rate on an airplane is really, really high. It's about 3 minutes of air.
It's got to be, because how easy is it for them to change the air?
Well, it's constant. So they literally, and it's basically coming in from the front of the plane and going out the back of the plane. So there's actually a steady airflow. So there's a case to be made if you're going to have a smoking section, put it in the back.
If you're going to have a coughing section, they should be in the back.
There you go. Yeah, because the germs flow backwards. That is true.
That's right.
All right.
Yep. Enough for that little geek out. Let's get to Better Know Framework. All
right, man. What do you got?
So I found this site that checks for malware, checks your websites for malware and security problems from the outside. So it basically, you enter a URL, and it's Sucuri, SUCURI.net. And you go there and you enter a URL to your site, and it checks the website for known malware, blacklisting status, website errors, and out-of-date software. And that part of it is free. Of course, they offer products to help you, once you do have a problem, to help you get rid of them.
Right. The same way that some of the malware scanners also will scan for free and then say, if you bought a retail product, it's even better.
And the reason that we had to do this, and the reason that I found it, was one of my sites had these weird errors, and people were getting, the error that should you proceed, this site is not safe, how the browsers do that. And so I went to a particular comment on using the Disqus engine, whatever they call it. And, warning, your computer has been infected with a virus. Do not close your browser. Do not turn it off. Press the button to clean it right now. Oh, yeah, sure. I'm going to do that.
Good old spear phishing.
Well, it turns out it was a problem with Disqus. And, they sell ads. And sometimes unscrupulous advertisers get through, and that's what happens. So that's what happened, and I basically had to turn it off on this particular website.
Interesting. I did scan RunAs Radio, and apparently RunAs is blacklisted, but only by Sucuri. Apparently Google and Norton and Site Advisor and Spamhaus and Yandex, they all think I'm fine, but Sucuri doesn't like me.
Huh, that's weird.
Yeah.
Interesting.
I'm always worried when a blacklisting site's like, I'll sell you a product because you're blacklisted by us.
Yeah, and everybody else loves you.
Everybody's fine. I'm like, okay.
Well, there you go. That's what I got. Who's talking to us, Richard?
Grabbed a comment off of show 1041, which goes all the way back to September 2014, which is not a coincidence because it's the last time Mr. Watson was on our show talking about .NET performance. And this comment comes from Brad Collins, who's asking a question about string handling, which is one of those, sort of intensive things, resource-wise, if you're not careful. And Brad says, what about string.format? How does it perform compared to string builder and other string concatenation? Many times I prefer string.format to concatenation because I find it more readable, which I think is a fair thing. Like, you got to read your code, right? Concatenation expressions tend to get long, so you end up having to break them up into multiple lines. Furthermore, there's the noise of opening and closing quotes and concatenation operators. How many times have you counted your left and right quotes over the years? In contrast, when you use format string, use it, it's shorter and you can see the entire string, so there's no noise to wade through. And Ben, at the time, and this admittedly is 4 years ago, said, generally string formatting will have worse performance than pure concatenation. However, the devil is in the details. If your concatenations aren't pure, that is, if you're calling toString with format specifiers, well, that's just formatting by a different name. And of course, nothing is the gospel truth until the profiler says it's true.
Right.
So test, test, test. Nothing else really matters. And I thought it was a good one. Just, thinking about the details of performance. And if you're doing lots of string manipulation, we've seen this over the years with .NET. You can suck up a ton of time in there. It's not an easy thing to do if you care about the performance for it.
Yeah.
So, Brad, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Google Plus and Facebook. And if you comment there and read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. Please.
It's like taking my wife, only different.
Let's bring on our guest. Ben Watson has been a software engineer at Microsoft for almost 10 years. There, he was one of the principal developers of a high-performance query platform in use by Bing, Cortana, Windows, Office, and Xbox, and other Microsoft services. Through the process, he became a passionate .NET performance advocate. He is the author of the book Writing High-Performance .NET Code, the second edition of which was just released. And in his spare time, he enjoys books, music, the outdoors, and spending time with his wife and children. And they live near Redmond, Washington. Welcome back, Ben.
Thanks. Great to be back, guys.
Yeah, it's great to have you back. And before we get started, I wanted to just say congratulations to the ASP.NET team for, making performance a priority and surpassing the highest, the most performant web server out there.
Yeah, they've done amazing work.
Yep, they certainly have.
And all built on .NET Core.
Exactly.
Yeah, I actually think it was a while ago. It was a few rounds back that they actually got to the top, because one of the big hits on the Tech Empower benchmark these days was the Spectre and benchmark, or Spectre and what was the other one? The two hacks on the Intel chip that forced them to decrease performance on them to make them more secure. And it's kind of thrown everybody's benchmark in a tizzy. Everything got slower and not symmetrically. So we're kind of at a weird time for benchmarking, because it's like, did you do those benchmarks with old processors or new processors? Old processors with the patch or without the patch? Like it's messed up. It's going to take a year or two to straighten that stuff out.
Yeah, we see that at work as well. When we basically do continuous benchmarking, and was this release better than the last release? Well, what happened in December and January, and all these releases of patches for Windows and just everything? It was really messy for a while.
Yeah,
and we had we weren't comparing apples to apples at all anymore.
No, Spectre and Meltdown are those two things that literally we're going to need a generation of processors to truly get over it. Maybe two, because Intel's restructuring the way their processors fetch memory, which the single most important thing they could do. And needs to say that, those performance tricks that they used had security vulnerabilities to them. So, yeah, crazy time.
Got to be fun working on processors.
Well, I remember, I don't know, it was like an Ask Me Anything with Guthrie, and somebody said, "What keeps you up at night?" And he said, a breach of Azure, right? Yeah. Which totally makes sense. Like that, the one thing that could truly damage civilization's move to the public cloud, like this is a change in the way civilization functions, would be a significant breach of a public cloud infrastructure, which, cross your fingers, has never happened so far. But when I looked at the specifications on these vulnerabilities, especially for Meltdown, I'm like, this is exactly the kind of scary thing. A breach where you could peek into somebody else's virtual machine on the same piece of hardware, potentially in the cloud. That, not that you could pick whose, not that you could pick what, but that you potentially could. And that, scary stuff. So needless to say, the patches came hard and fast.
It's just amazing how many of our vulnerabilities come from an era where they weren't thinking necessarily about security. You look at all the DNS issues we've had. It's just very fundamental infrastructure just has this flaw that's been baked into how it works for so long. And, it comes out a decade later. It's like, oh, this thing that we all rely on is now just fundamentally broken.
Mm-hmm. And was built with the best intent. Right? They, in most part, like just they were academics. The web was a bunch of academics just trying to link their papers together. You made it into porn. Like, how did that happen?
Right.
So I'm always fascinated how when you guys improve performance, right, that it just seems like magic to us. But, what kinds of things do you do? I mean, are you just simply doing telemetry and on how long everything takes, and you look at the things that take the longest time and have the highest latency and say, how do we improve that? I mean, is it just that simple, just going down the list? And what kinds of improvements do you do? Do you move memory around? Do you move things into the same process? Like, what's involved in that?
Yeah, I think in some ways you're exactly right. That is all it is. It's, on one level, it really is just profiling what's at the top of the profiler and going after that. I mean, that's really the best thing you can do in any situation. But it does get more complicated. It's not just about CPU anymore, especially with .NET. Arguably, memory allocations are more important. And then these days, especially, it comes down to threading issues and processor cores, and is hyperthreading turned on, and caches. Like, with so many threads going on with hyperthreading, for example, it looks like two threads to your computer, but they share the same cache. That can be an issue. So it can get really messy really fast. But theoretically it starts easy. What's my most expensive thing? Okay, how do we make that not the most expensive thing anymore? And iterate, repeat forever, because you're never done.
And is this just a fresh set of eyes looking at old code, now knowing that this is a performance important piece of code?
Yeah, I think that can definitely happen. As much performance work as I've given code in Bing and the platform, we have new guys come in, and I don't work on that specific area anymore. I haven't for years. They come in and they look and they say, hey, why are we doing this way? Right. Why don't we change? And I can go, it was supposed to be this way because of this reason. And that's not really a valid reason. You should go fix it. And, absolutely, new sets of eyes can find something that even the experts can miss.
And I certainly learned from my time doing lots of web performance was you don't tune everything because you can't, and you really need to know what needs to be tuning. So I never cast bad intent on any person's piece of code. It's like, this code works. It's just so popular that now it needs to work faster.
Exactly. Like your patterns can change. Your scale can go up. You can get just completely different types of data processing. Everything changes, right? No system is static. If it's static, it's dead. So it's, performance work is continuous work. It's never end. You never say, well, we've shipped performance. You're always shipping performance.
Not a feature, yeah.
Well, and just a call back to that Tech and Power benchmark. It's like, .NET may have climbed to the top of it at one point, but everybody else is trying to get faster too. So the tides of performance change constantly. It's not a bad thing. Everybody pushing each other to be better is a good thing.
Absolutely.
It's a very good thing. Yeah.
Well, one of the things I like to tell people about here is compare the performance over time with .NET Core and just how my recommendations have changed vis-a-vis .NET Framework.
Right.
At the beginning, .NET Core is just open source. It was great. It couldn't do everything .NET Framework can, but if you need to do portable libraries that work everywhere, you can do most of the base stuff, and it's great. And that was kind of it. There was no real performance dimension to it, except theoretically, it's like, okay, now the masses can start contributing to .NET and improving things, but we weren't really seeing that. We didn't know what was going to happen. And now it's like, there's been another massive release with thousands of perf improvements. And I go to the .NET team and say, hey, can we pretty please get these in .NET Framework? These are awesome. We need these. And they usually do, but it moves so fast you can't keep up. And it's just now, it's like, why wouldn't you be on .NET Core? And now when I go to the .NET Framework team, they're like, can you just please move to .NET Core? Everything you want is there. And you'll get it there faster. You don't have to wait for a new, .NET Framework Windows release, because .NET Framework is essentially a Windows component now.
Right.
So it has to go through all that extra stuff. And .NET Core is just like, hey, it's open source. You get a new build, you get all the latest stuff, and party on.
Rock on. Yeah.
And as we saw with Build and Scott Hunter and Hanselman's talk, and we did a show with Scott as well, Hunter, Core 3 is starting to bring across some of the UI components, although they are new versions. They're somewhat different.
Yes.
Yeah. The windows of .NET Framework parked on top of .NET Core.
Yeah.
Great.
And I think that was the weakness of .NET Core, is like, hey, this is great for server apps, for portable libraries. And now it's like, no. Now we can do everything. And I'm sure we will eventually transition to everything is .NET Core.
Yeah.
With, platform-specific libraries.
Right. And still protecting, if you've got to stay on Framework because you're not going to re-engineer the site, I think Hunter did a really good description of, look, we can make high-def WinForms, ones that scale well with high DPI screens, but not without breaking your old code. So we're going to make a new WinForms that's got all the same calls and so forth, and this is the one that runs against Core. And so you can make that migration and then deal with the changes, but we won't break your old one.
Yeah, it's great. Yeah, so exciting times. I have to poke some of my sources inside and say, hey, are you going to be transitioning this particular API as part of this, or this other particular API? Yeah. And we'll see. But yeah, I wish I could use .NET Core at work, because it's exciting stuff. That's where all the love is.
Absolutely. And Ben, give us one moment here for this very important message.
Support for .NET Rocks is brought to you by Conversational UI from Progress Telerik and Kendo UI. Conversational UI are chatbot framework agnostic user interface controls and components that enable .NET and JavaScript developers to create modern conversational chatbot experiences in their web, mobile, and desktop applications. The industry's first packaged set of user interface components built specifically for chatbots are available as part of Telerik's ASP.NET Ajax, ASP.NET MVC, ASP.NET Core, WinForms, WPF, Xamarin products, and Kendo UI for jQuery, Angular, Vue, React, PHP, and JSP libraries. By implementing key UI design features such as calendars, date pickers, list views, and others that are included in the toolsets, developers will be able to improve chatbot conversation through visual elements. For more information, visit telerik.com/conversational-UI.
And we're back. Richard Campbell, Carl Franklin. It's .NET Rocks in the studio, recording out of order, because we knew if we were going to talk to Ben about .NET performance, we had to do it after build. So even though we're publishing this ahead of the other build shows that we recorded, we're just cleaning up the order here, and certainly an important topic, this writing performance code. And you got a new update to the book.
Yeah. I think first edition came out in 2014.
Right.
And so it's about 4 years old, and I wasn't really planning on doing another edition, but I kept seeing feedback that's saying, oh, this is 4 years old and computers move so fast. I was like, all right. And it's, there are lots of updates, and, there's a little bit more mention of .NET Core, and a lot of people wanted more coverage of Visual Studio, which I had mentioned, but I don't use Visual Studio for perf analysis as much, just because of the nature of my project. So I probably let a little bit of bias creep into the first edition. So I fixed that. But it's really interesting to see what has changed and what hasn't over the last 4 years. And I think a lot of people assume, 4 years, everything's different.
Yeah.
And the reality is, a lot of the stuff on the surface is different. Like we were just saying with, .NET Core 3, we're bringing all the Windows stuff and all the desktop stuff onto Core 3. So there's lots of new APIs, and they keep, iterating on all the flavors of .NET and adding new things and new features. But the core of .NET, the garbage collector, the JIT, those do receive iterations, but those fundamental principles of performance, those haven't really changed much. So it's been more of an iteration and, fleshing out a lot of the explanations, giving more examples, and then also covering, SIMD architecture and just, StackAlec, a couple other things that just weren't in the first book, just oversights. And more stuff with threading. That's going to be the real, I think, frontier of performance engineering in the future is how do we make everything parallel? Because CPUs aren't getting that much faster that quickly. So we're all going to have to become the multi-threaded engineers.
And that brings up another point, which is as great as the framework is performance-wise, you can still write non-performant code and shoot yourself in the foot. So, what do we do to avoid those situations?
.NET makes that so easy to do. It's
right.
I love .NET. I love C#, but yeah, it's the syntax and the libraries are just, hey, .call, use link, do all these great patterns, and it hides all of the stuff from you. So you have to understand what's going on under the covers to see if you're getting good performance. And
right. Yeah, we don't recommend retrieving 1 million rows and then just using a link in memory search to find the things that you need, for example.
Yeah, that's all one line of code. How slow can it be? Yeah, so I think a lot of the effort in my book and in the talks I give is to unpack that a lot. And I do give specific link examples and other API examples where, hey, this really simple query translates into 5 allocations and 4 method calls and exception handling and possible exception throwing. And you could just replace it all with a single for loop that has none of that.
And you'd think that terseness would mean performant, but especially with link, it's just not true.
Yeah, it's not. And it's not true with a lot of things in .NET. TPL or async await, for example, that hides stuff from you. I don't think that's quite as egregious.
No.
It's mostly just TPL.
Yeah, and it also takes advantage of the threads that are already out there and being used.
Right.
And if we can, sidle up to the UI thread and do everything without affecting things, we'll do that.
Yeah.
It does occur to me that async await was brand new when you came out with the first edition of the book. Like it had shipped in 2013.
It was. I had barely mentioned it, so I did expand coverage of that and give some more examples. Brought on TPL Dataflow, which is a cool library for building workflows of independent processing and just automatically. It's like, hey, this output goes to this input. You figure it out. And, take away, it's another level of abstraction. And so at the same time, I'm describing all these levels of abstraction. I'm also saying, well, you really have to understand what goes on under the abstraction layers, because in many cases, great performance is about removing layers of abstraction.
Right.
Well, and also, that's so critical. And here's just a simple example, the parallel for. Parallel for each and all those things in TPL where if you're iterating through a list or something.
Yeah.
I'm scared to use that because I know that a tight loop, there's nothing faster if as long as you're, out of it pretty quickly. But, what's the guidance on using those? When does that make sense?
Yeah, it comes down to measuring it and understanding if the single loop iteration is if parallelizing that is cheaper than the overhead of scheduling that thread.
Right.
You must have a lot of items to iterate through if that's going to actually do anything for you, huh?
Well, or each item, depending on what you're doing in the loop, is very expensive.
Right.
Yeah, each item is expensive, right?
Yeah, then it makes sense. And you've got the cores available that you can say, hey, just do as many of these items at the same time as you can. There's no interaction between them.
Right.
That's another thing. If you put a lock inside your parallel loop, well, you no longer have a parallel loop. And I've seen that before. There's like parallel.for, open bracket, lock.
What are you doing?
Yeah. So, yeah. And, parallel programming, asynchronous programming, it's not the same thing. You have to think differently. You have to get in that mindset. It's not a matter of just sequencing the syntax elements one after the other, and then you get the answer out the other side. It's understanding how is my data used? Who else is using this data? Do I have two threads sharing this data? Are they doing it in a read-only manner, or do they need to mutate it? If they can do it in a read-only manner, well, then there's no synchronization needed.
Right.
Can I change my processing to make everything immutable so that I can, throw 30 cores at it at once? If you can't do that, well, then now you have to do synchronization. So then what's the best kind of synchronization? And I generally default to simpler is better until proven otherwise. There's almost no reason to use any of the fancy locking mechanisms until you really, really understand what you're doing and you can really prove it.
Yeah, it sounds like that's only something you put in after you've demonstrated that you have problems.
Exactly.
Yeah.
It does occur to me that, the challenge here, especially when you're measuring granular bits of code, is that as we expect that we have more cores available, which we tend to have, and you can do more asynchronicity, I'd rather have a given process take 20% more time, but I can run more of them simultaneously. It's like, hey, here's these 4 steps I need to do. Each one of them takes 4 seconds, and 16 seconds is too long to wait. But I can run them in parallel, and they all take 5 seconds to do, but they all run at the same time, which means the whole thing takes 5 seconds.
Exactly. You have to do that kind of analysis, and you have to figure out how you can scale, right? It's very analogous to, do you scale, vertically or horizontally? Do I need more machines, or do I just need a more powerful machine?
Right.
And it's a similar problem to that. Some problems don't scale very well with more machines. Some are just going to be fundamentally bounded by the CPU or the memory that you have on that machine and the number of cores you have. And you've just got to make do with that.
I would also say that's a great situation to be in. If the solution to going faster is more hardware, there's more hardware available.
Right.
Yeah, there is, but you have to be careful there too, because that is often the first thing that people run to. And I think that's a bit of a mistake.
Sure.
Because people assume like, oh, our software is slow. Let's just throw more machines at it because another machine is cheaper than putting a developer on it for a year. And I'm like, well, okay, first of all, if your developer learned a few things in 30 minutes that drastically improved the performance of your code, that's cheaper than a new machine.
Yeah.
Mm-hmm.
Also, for many companies, I think about Microsoft and the huge data centers we have. If we make things run twice as fast, that's half the number of machines, and we're talking thousands of machines.
Right.
So
That's
thousands of high-end servers is very expensive.
Yeah.
So it might make sense to put half a team on just fixing this one problem if you can improve the performance by 50%. Now, 50% is a lot, but I have seen that happen.
Absolutely.
Wow. Hey, Richard.
Yeah, buddy.
Guess what time it is now?
Must be that happy time again.
Yep. It's time to reveal the real internal code name for .NET Core 2.1.
Oh.
Viagra.
Contact your doctor if your performance increases for more than 6 hours.
.NET Priapism.
Nice.
It's actually time to give away a DXperience subscription from our good friends at DevExpress to one lucky member of the .NET Rocks fan club. Everyone knows that DevExpress has great desktop controls, but their web tools are great also. They're simply amazing. They have this collection of HTML5 JavaScript controls called DevExtreme. And at the heart of the product line are these really powerful controls like grid, chart, pivot grid, tree list, and scheduler. But DevExtreme also comes with more than 50 touch-optimized client-side controls, data visualizers, navigators, editors, lists, dialogues, and notification controls, and general-purpose controls like a filter builder, range slider, file uploader, scroll view, and more. Now, since they're all HTML5 JavaScript CSS, they include integrations with things like jQuery, Knockout, React, Ionic, and Angular. Plus, DevExtreme controls come with ASP.NET MVC and ASP.NET Core wrappers, so they're infinitely flexible. But don't take our word for it. Go for a test drive at dx.netrocks.com. That's dx.netrocks.com.
All right, buddy. Who's our winner?
Today's winner, Richard, is Linus Andrain.
Congratulations, Linus. Golf clap for you, sir.
Linus just won the DXperience subscription, a big pile of awesome from our friends over there at DevExpress, just for being a member of the .NET Rocks fan club. And if you'd like to be a member of the fan club, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the club. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the fan club. But you got to sign up to win. And we also like to ask our guests, Ben, if you had $5,000 to spend on technology today, what would you buy?
Ooh, technology. Well, I have been very interested in getting back to my roots a little bit. And when I was a teenager, I've played piano and done music most of my life, but as a teenager, I focused a lot on synthesizers and writing music and learning to compose. And so probably some music equipment and, digital audio workstation type stuff and some nice speakers and things like that. That's where I've been trying to get back into music and feed that creative beast.
I definitely feel that.
Yeah, no question. And it's interesting what it does to your brain.
Yeah.
To exercise those different pieces. Like, it makes you better at everything else too.
I got an amazing collection of sounds that you can trigger with any MIDI instrument called Native Instruments Complete.
Oh yeah, I'm familiar with that. I don't have it, but it's on my list to look at.
Yeah, it's very good, and we're talking about drums sampled from Abbey Road. We're talking about great grooves, ethnic music, sounds that you've never heard before. Just great pianos, a whole bunch of great pianos, great acoustic instruments, brass, strings, just amazing breadth of sounds. Anyway, I feel you.
Yeah, so you like Contact?
Yeah, it's okay. I mean, I'm just using most of the sounds myself. I don't really make my own samples or make my own sounds from samples.
Right.
So I just go for what's there, and then I modify them just with audio, with effects and EQ,
right,
to control them and make them exactly what I want to hear.
Yeah, I've been teaching myself with some of the old music that I'd written when I was younger, just loading it up in Cubase and getting a good virtual piano and applying the EQ and mastering and all that kind of stuff, and great process. So much fun.
Lots of fun, definitely.
Yeah.
Getting back into this, I think it was Joe Duffy in a very early show. It was less than 200, maybe in the 150s, 160s, but he told, I was talking about doing multi-threading and concurrency back then. We didn't have all the stuff we had now. We had threads, and I believe we had the asynchronous model, but I was working on handling, multi-threaded servers and that kind of stuff and sockets, and trying to figure out what was the best way to, put locks on code that gets called per client. And he gave me a very astute tip, which is typically you don't want to put locks around code. You want to put locks around accessing the shared resources.
Right.
Yes, exactly.
Like if you've got a big collection that you're going to pull from and send out to a bunch of people, you want to lock that collection while you're doing that and then release it as soon as possible.
Yep. Yeah, there's a hierarchy of synchronization primitives that you want to use, and at the very top of that hierarchy is no synchronization necessary.
Right.
But it often requires you to really architect and design your program very well so that you can ensure that at most of those points where that data needs to be shared, it's read-only, it's immutable, or it's not touched by multiple threads.
Right.
And most people, I think, could do that if they really sat down and thought about it. Most problems can be reduced at least partially to that model, but it can be really tricky to do that. Especially for everything.
This is very much the functional mindset, this immutability by default mindset that just lends itself to more parallelism.
Yes. And there's trade-offs, right? You could take that to the extreme and say, well, I'll just make a copy of all the data that I need to share. I'm like, well, all right, now you're just buying other problems.
Yeah.
Does that mean when one client changes it that you have to copy the whole thing again? That's just kind of silly.
Yeah. Yeah, and there's other models too. You could have copy on write, which those kinds of things are built into the OS at all sorts of places, and you can do that in your own program. But, if you can't get that pure immutability, then, restrict the scope, use simple locking protocols, really figure out exactly how that data needs to be shared and why. It's not just a matter of, well, I know this needs to be read by another thread, so I'm going to put a lock on it just to be safe. It's really understanding the data access at a very deep and precise level.
Yeah, I'm very grateful for frameworks like SignalR, and the queuing system and all of these great things that just deal with it for you.
Yes.
It's just such a luxury.
If you have the option of using a framework that does what you want, then use it. Because you're guaranteed to get it wrong in the first 20 iterations.
Right.
Don't write multi-threaded code.
Yeah.
Don't do that.
Don't do it unless you have to. And then if you have to, look again.
Yeah. Be really, really sure. But task parallel library strikes me as a safer way to go about it when you start thinking maybe more threads would help me. And at least you're living in a framework that does some smarts and sort of protects you from yourself.
It does. It does in many ways. It handles the threading aspect of it very well. It doesn't necessarily help you with that data protection, the synchronization part as much, but it does help you. It's like, okay, I know I got a thread pool. What's the easiest way to use the thread pool so I don't waste time spinning up threads? What's the easiest way to just call this method, and then when that method's done, call this other method? So it makes it very easy to structure your application. But the synchronization and data protection is still on you.
Yep.
So I've been forced to use task.run a couple of times, which is great because if you've got some code that isn't, if you've got a method that isn't yours and it's not asynchronous, you can just wrap that in a task run and await that, and it'll work. In fact, you could just task run and have an anonymous method and just do it yourself. But so what's the difference between doing that, under the hood, task run versus async await versus, say, making a wrapper function that's async and then, you still have to call it. You have to await it somehow.
So if you're just going like using threads directly, or the old asynchronous programming model, I think is what they called it, where you have the iasync result type of thing. Those methods are still there, but I just think of them as deprecated. I mean, those are using threads directly, right? And you have to hook everything up, and it's very low level. It's not Win32 low level, but it's low level for .NET. It feels clunky, especially today. TPL is one layer above that, and just makes it look much more like C#. I almost think of the iasync result APIs as this kind of feels like C++ programming.
Yeah.
And TPL is very object oriented. You have continuations, and you can just call .wait. If you really don't care about performance, you can wait on things. But async await is a, I don't want to say syntactic sugar. I think it's more than that, but it is a different way of interacting with TPL. Underneath, async await just becomes TPL calls.
Interesting.
It does have its own features, but the cool thing about async await is it makes your code look easier.
Right.
It makes it look synchronous. And I have an example in my book, actually, where I take some compression code. I think it's reading and writing a file. It's reading from a file, compressing it, and writing it out to another file. And I first wrote that completely synchronously, like, stream.read, and then stream, compress, stream.write.
Yep.
And then to make that asynchronous, well, if you use TPL, it will look very different. Like, you're going to have continuations and callbacks, and you've lost the structure of the code. And if you're used to that, that's fine. But if you introduce async await, now you just decorate these methods. Instead of calling a read, you call read async, write async, and your code looks 99% the same.
Or you could just do await task.run with a lambda to the call to the synchronous code. Right?
Yes. Yeah. So there's lots of ways of interacting with it, but fundamentally, it all goes back to TPL and scheduling these threads and these callbacks in a way that's very easy to interact with.
Yeah, it's very cool.
I'm also fascinated by the prospect that they did actually make it faster.
Yeah. Well, that's where benchmarking comes in.
Yeah, you've got to have good benchmarks, and I've certainly seen cases where folks have gone and spent days tinkering with things like TPL and just come up with no significant net benefit.
Yeah. You really have to understand your constraints. Are you really limited by CPU? Does it make sense to process something in parallel? Do you have enough resources to process it in parallel? If you do split it up, are you now introducing another constraint?
Right.
Maybe you're reading stuff off disk, and when you're doing that serially, the disk is not a bottleneck, but now it is. If you've got 32 threads all trying to read different places on the disk, well, you might have just made it worse. And maybe you just throw an SSD at it, but that, it's a balancing act.
Yeah, if you're going to fix it with hardware, you shouldn't have tinkered with the code, right?
Yeah, exactly. You've really got to think this stuff out. Performance engineering, as I said, on one level, it's finding the most expensive thing and fixing it. But on another level, that interaction between software and hardware is getting ever more complex because there are so many options for you to change the performance constraints of your hardware, and you can drastically affect things. And with .NET, I think it's in some ways more complex. We have better tools to find it, but there are more things you have to look at.
Yeah, if you talk to people who are total whacks on performance, that's all they think about. They start talking about not using .NET at all. Living in a garbage collected, memory managed, JITted world is just an anathema to performance nuts.
Yeah, and I don't go that far.
Yeah.
I mean, there are certainly problems that need that approach, but my approach is I'm not doing things on the nanosecond level. I'm doing things on the microsecond and millisecond level. And .NET is more than enough for that.
I totally
better
agree.
than most people think.
My usual response to them is, the one thing I know for sure with my .NET app is that my performance problem is not caused by memory leak.
Yeah.
That's what I know.
Yeah. Well, you'd be surprised. You can definitely have memory leaks.
Yeah.
A cache that never lets anything go is
a kind of memory leak. It's not.
But you can optimize the garbage collector if you understand the garbage collector, and that's a big part of the education I do. Is like, hey, look, if you understand how the garbage collector works, you can drastically improve the state of your performance just by understanding that and making a few simple tweaks to your code. You will no longer spend 50% of your time just collecting memory, which seems to be the default state for some people who start and it's like, oh, allocate here, call this. It's like, no. Understand how this works and play to that. And you can see huge improvements.
Where I've seen a big problem is with disk write cache.
Yeah.
Many hard drives come with that enabled, and that causes all manner of problems. Why do they do that?
Just in I/O getting backed up, or?
Yeah, but and also loss of data. I mean, when you talk about asynchronous code, I want to write to my file system asynchronously. But the problem, of course, is if you call two writes to two different files at the same time, you still have a physical limitation of the disk is only going to do one of those at a time, right? That's to put it in a queue and then process that queue on a different thread synchronously.
Yeah.
Isn't it?
Yeah. There's no one right answer. Right? It's about measuring and seeing what happens when you tweak different things. It can get real tricky when you get the hardware involved. If you're maxing out the disk, sometimes there's no great answer if you're just pegging that disk and things are getting lost in the buffer. Yeah, got to rethink things.
When it comes to tinkering with garbage collection, is there really anything I need to do beyond just go GC collect?
Well, you shouldn't do that.
No place to start.
Yeah, you shouldn't call GC collect unless you know you need to, right? And that's the thing, is you have to understand exactly why you should never call that. And then you have to be able to say, I am disregarding that because of whatever reason you have, because I know better. And there are situations where you can know better, but I would say 99% of people don't.
Yeah.
The thing you have to understand with GC is the time it takes to perform a GC is proportional to the amount of alive memory there is. So if you have a lot of memory. You could have 1 million objects, and if they're very temporary and you use those 1 million objects and then there's no more reference to them, the GC doesn't even see it. So it takes no time to process those 1 million objects.
Right.
But if you have that 1 million objects and you keep a reference to it, and then a GC happens and it has to traverse those 1 million objects and it has to promote them now to Gen 1, and then there's another GC that still sees those 1 million objects. Now it's in Gen 2. Then that's when you start running into problems. You want to avoid that kind of promotion. You want the pattern of my memory allocations come in, they go away, the memory lives very short, very ephemeral. We call those ephemeral allocations. Or you want memory that lasts forever.
Right.
So it essentially goes into Gen 2 and stays there forever. Essentially, it becomes a memory lake. It's pooled.
but a valuable memory lake, right? Good cache objects sit in Gen 2, and they tend to be large, which is why we cache them, and they're stable.
Exactly. And you reuse them over and over again. So that's the pattern you want. If you can master that pattern, there's a lot of other tricks and ways to optimize your code, but that's the fundamental way the garbage collector works. And if you can do that, then you're well on your way to reduce the amount of time the GC spends in your code. It
really is a little cognitive dissonance for most people, I think, because we've made programming easier with the .NET framework for mere mortals to do amazing things. And then on top of that, we're talking about Gen 1 and Gen 2 and, CPU rings and things. And it sort of goes over most people's heads. But I guess what I'm saying is, if this stuff sounds like gobbledygook to you, you might want to make friends with that nerd in the company who does get into this kind of stuff and just, ask for some guidance based on your code. Or it's actually not all that difficult. I mean, especially when it comes to the garbage collector. You just got to do a little research. That's all.
Yeah, it's just knowledge. And unfortunately, you can find bits and pieces of it throughout the internet and on Microsoft Docs. But getting an overall picture of, this is how you write good .NET code, that can be a little difficult because especially, like you said, when you start out, it's just so easy and you can just get into it and you're done. Right. You've written your program, you walk away. The other thing I tell people is the amount of effort you put into performance needs to be proportional to the amount of performance you expect out of the system. If you're just writing toys, probably don't care. Just write your toy and be done. But if you're running something that's going to run on 1,000 Azure instances, well, then you should probably think about this a little better because you're paying for that. Yeah. Every cycle, if you're using Azure Compute, you're now paying for CPU. It's no longer a sunk cost for you.
Right.
And it needs to be proportional to the need. And so, most people don't need to optimize to the nth degree for GC. But if you do, well, you've got to expend the effort, learn what you need to know, and keep iterating on that to eke out better and better performance. And you could eventually get to the point where it's like, well, .NET just isn't going to work. But I don't think that's most problems out there.
Yeah, it seems like a very rare scenario. And I would think if I got pulled into something like that where they're starting to talk about that kind of timing, it's like, we're in the wrong place. Like, what are we doing? Yeah. What can we pull out of this and do a different way to deal with those millisecond timings?
But I would say this, in .NET, memory is CPU.
Right.
You're paying for it one way or the other. And, especially these days, more and more people are now paying others for CPU cycles. So you no longer in your company just have a computer that you can do whatever you want on. It costs $2,000, $5,000, whatever, and you can just use it. The electricity might be negligible, and it doesn't really matter. But now if you're scaling up, you need thousands of machines, and now you're paying Microsoft for it because there's only Microsoft Azure, of course, right? That's all there is. Just want to let everybody know. You're definitely paying Azure for your compute cycles. Well, now your optimization might really matter to the bottom line because you're now paying per minute or per machine or whatever it is. There's a much stronger correlation between the performance of your code and how much money you spend running that code.
It's at least more measurable.
Yeah.
I kind of like this idea of getting to a place where we could start doing dollars per transaction, both in and out. And then, because we did a lot of years working in the e-commerce space where I would look at performance tuning and break it down. We knew what the revenue per hour of that e-commerce site was, and you could make a case for a budget for 3 people for 3 months to get this kind of return. You'd hypothesize we're going to shave this much time. We expect this revenue increase. Heck, I built an appliance on the back of that idea.
Yeah. I think that's going to become more and more important. People are going to start looking at that and it's like, hey, why are we spending 1,000? Why are we paying for 1,000 servers when 500 will do? Can we get to 500? Can we get to 100? And with all the sloppy code that I've seen, I'm confident many teams could reduce their CPU load by 90%.
Yeah.
On the other hand, don't do this because the more you pay Azure, the better my stock looks, and that's what's paying my salary. So don't do it.
Don't do it.
That's great. So Ben, are there any other resources that you want to mention before we sign off here? Stuff we can link to? Your blog, for example?
Yeah, I'm not a strong blogger, but I am throwing stuff out there. I'll be doing some more in the next few months. My blog is philosophicalgeek.com.
Love it.
Awesome.
And I've had that forever, and I'm putting stuff up there. And the book is you can find it everywhere books are sold, and enjoy it.
As long as it's on my Kindle, and it's on my Kindle, then it's real.
You can get it on your Kindle.
That's it.
Awesome. Thanks, Ben. It's been great talking to you.
Likewise. Thank you so much.
You're welcome. And we'll talk to you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1. Recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC. Yes, I'm a